Hello everyone, my name is Vassilis Nikolaidis, and I'm assistant professor in the Department of Electrical and Computer Engineering at the Democritus University of Thrace in Xanthi, Greece. In the next few minutes, I will present you the paper entitled "A Software Tool for Impedance-Based Fault Location in Power Transmission Lines." In this slide, you can also see the co-authors of this paper. The problem of fault location in power transmission line is to find the exact fault position on a faulty line. In this way, the restoration time and the time of supply interruption is reduced, improving system's reliability. There are different fault location algorithms developed so far in the literature. We focus in this work on the so-called fault impedance-based fault location methods, which are based on fundamental frequency measurements-based phasors to estimate the fault position. There is always an error in the estimation of the fault position because of inaccuracies on the measurements taken from the field, and of course because the exact line parameters, especially when the earth is involved in the fault, are not known exactly. All fault location algorithms try to minimize this error. The software tool presented in this paper provides to the user 11 different fault location algorithms coded in MATLAB. You can see the algorithms here. There are algorithms that are appropriate for single circuit lines, for double circuit lines, with or without compensation, and they are based on measurements taken from one line end or from both line ends. In this slide, you can see the graphical user interface of the software tool, which is developed in Simulink in this case. In the blue box, you can see the transmission line under investigation. It is modeled in two parts in order to simulate the short circuit fault in the desired distance from the line end. The equivalent external sources and the equivalent transmission link connected in parallel to the transmission line under investigation are also calculated with the use of another algorithm which tries to reduce the external grid around the transmission line of interest. The user may choose the desired fault location algorithm. They can choose the desired fault distance, the fault type, the compensation of the line if it exists, the fault inception time, etc. The fault locator takes measurements, instantaneous voltage and current measurements from both line ends. It includes the signal processing unit, which filters these instantaneous voltage and current measurements and extracts the respective voltage and current phasors. Based and depending on the fault location algorithm used in the analysis, based on these phasors, the fault distance estimation is calculated. The IEEE benchmark system for voltage stability analysis is used for the simulation runs. In particular, we applied the short circuit faults in three specific lines, namely on the 400 kV single circuit line 4045, 4062, this one. On the 400 kV double circuit line 4022, 4031, this one. And on the 400 kV single circuit line 4032, 4042, which is compensated with the use of a series capacitor. We applied all common fault circuit types, namely the three-phase, the double phase to ground, the double phase, and the phase to ground fault on each of those lines, and along these lines at every 10% length. And for each of those short circuit scenarios, we assumed different fault resistance values. In total, 648 simulations were conducted. we see in this slide, in the table on the right, indicative results for a particular short cycle fault, a single phase to come fault. In the middle of those lines, we can see the results, which is the fault distance estimation error obtained for each of those algorithms. The user may retrieve for each of those short circuit faults, this case is the relevant plots. For instance, on the top, one can see the evolution in time of the fault distance. This last expression is due to the short-term tangents immediately after the fault. In the figure on the bottom, one can see, for example, the dependence of the fault distance estimation error with respect to the fault resistance values and the fault distance, the actual fault distance along the line. Let's conclude the presentation. A user-friendly software tool is developed for conducting fault location studies. Diverse transmission systems and fault condition may be analyzed with the use of the software. Any transmission line and any power system can be analyzed due to the external grid equivalencing algorithm developed in this work. 11 different fault location algorithms have been developed, but the software tool is fully extensible. It's only a matter of coding in MATLAB the new algorithm and including this in the software tool. Thank you very much.
Thank you, Vassilis.